All right, so starting on 41, what is inertia? It's the tendency of an object to resist a change in its motion. In other words, an object at rest tends to stay at rest, and an object in motion tends to stay in motion. All right, 42, what direction would a person go if they were in a car crash? Why? They would continue going in the direction of the car was going in due to inertia. So if you get hit from behind, you're still going to go forward. That's why you have your seatbelt on. Okay? So if you hit a concrete wall and you're going whatever, you're still going to go forward. So that's why you have your seatbelts. And then on page 364 to 365, there's a thing on car crashes and dummies. Please read that. You do know that if you hit a concrete wall and you're going like 65 miles an hour, you're going to hit the wall going 65 miles an hour. Okay? And if you don't have a seatbelt on, you're going to leave the car going 65 miles an hour. So, like if you're on a motorcycle going 120 down 40 and you get in a wreck, you're going to come off of it going 120 and you're probably going to die. All right, 43. What is Newton's second law state? The acceleration of an object is equal to the net force acting on it divided by the object's mass. So, 44. What is mass? It's the measure of inertia of an object and depends on the amount of matter the object contains. So the more mass it contains, the bigger the inertia, basically. The less mass, less inertia. What is the formula for Newton's second law? It's acceleration equals force over mass. However, you can use force equals mass times acceleration too. Just depends on what you want to solve for and what's easier for you. 46, explain how seatbelts work according to Newton's second law. This is on page 367. When you're in a crash, your body keeps moving in the direction that your car was moving, and your seatbelts tighten to slow you down and absorb the energy. And then I said on here, workout problems 367 to number 1 through 4 below. 47, what is weight? It's the force of gravity acting on an object's mass. So the formula we use for weight is weight equals mass times acceleration due to gravity. So the formula is weight equals mass times gravity. You can also just take this G out and make that an A. Acceleration and acceleration due to gravity are basically the same thing. Okay? So really, acceleration equals force over mass, gravity equals mass times weight equals mass times gravity, and force equals mass times gravity. Acceleration are all the same formula. Okay. What is the unit for weight and why? It's newtons, because it's the weight is the force of gravity. What's the value for G? Gravity on Earth, as far as I know, I didn't check today, but it is 9.8 meters per second squared. No, it does not change every day. 51, explain the difference between weight and mass. Mass is a measure of the inertia of an object, and weight is the measure of the force of gravity acting on an object. So 52, what would change if I went to the moon from Earth? My weight would change. My mass would not. I would still be the same size in mass, but I would weigh a little less on the moon. A lot less. Okay, because the moon is 1.6 and Earth is 9.8. So that's a big difference. All right, 53. What does Newton's third law state? Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. What are these forces called? Action-reaction forces. 55, action and reaction forces are always equal in size and opposite in direction. So 56, explain action-reaction forces for a hammer and a nail, and then you pushing on a wall, and then you swimming. So the first one, a hammer applies a reaction force to the nail, and then the nail applies a reaction force to the hammer. You push on a wall with the action force, and then the wall pushes back on me. And then swimming, we talked about this one. I push back if I'm doing like the front crawl freestyle. I push back with my hand on the water, and then the water is going to push my body forward. Do all action-reaction forces produce motion? No, I don't move a wall. It's because my force is not big enough for that. Why do action-reaction forces not cancel each other out? The forces do not act on the same object. 59, what is momentum? Momentum is the product of an object's mass and its velocity. 60, explain how an object could have a large momentum. It could have a large mass but have a low velocity, or have a small mass and a large velocity. So, for example, if I have never mind, it's down here in number 63. So, again, you could have a large mass but going slow, or you could have a small mass but going really fast. So, the formula for momentum is a special P equals time velocity. So, it would be P equals M times V. The unit for momentum, again, is kilograms times meters per second. Remember, kilograms times meters per second squared is a Newton. 63, explain the difference in the momentum of a fast-moving golf ball and a slow-moving bowling ball. This is an example of a golf ball having little mass but going really fast, and a bowling ball having a lot of mass but going very slow. Okay. 64, what is the law of conservation of mass? If no net force acts on a system, then the total momentum of the system does not change. The momentum is conserved, which means no mass is lost or gained. What happens to the momentum in a closed system when two objects collide? The loss of momentum of one object equals the gain in momentum of another object. Mass is again conserved. And again, the train scenarios on page 376 really show what I'm talking about. 66, what are the four universal forces? Electromagnetic force, strong nuclear force, weak nuclear force, and gravitational. What is the electromagnetic force? It's associated with charged particles. 68, the electric force and magnetic force are the only forces that can both attract and repel. 69, what are electric forces? They act between charged particles or particles such as electrons and protons. Like charges, number 70, like charges are going to repel and opposite charges are going to attract. 71, explain static electricity between clothes. So, you know how like when you get something out of the dryer and it's all staticky? This is why. Cotton clothes lose their electrons, so they're positive. Polyester gains electrons and they're negatively charged. So that's why if you have like nylon shorts, like basketball shorts or nylon, and then like a t-shirt, it'll stick to it. Or ladies, if you have like kind of satiny underwear, they stick to cotton. So that's why. What are magnetic forces? I'm sorry, you guys maybe have satiny, soft underwear. I'm not sure. Didn't mean to, leave you out. 72. What are magnetic forces? They act on certain metals. Like iron is magnetic. Magnets have two poles, a south pole and a north pole. Like poles repel, opposite poles attract. Let's see, 73, how are they attracted to each other and how they're repelled, see above. 74, what is a strong nuclear force? It's a powerful force of attraction that acts only on the neutrons and the protons in the nucleus, holding them together. A weak nuclear force is an attractive force that acts only over a short range and affects all particles, not just protons and neutrons. Shorter range than nuclear force. 76, what is a gravitational force? It's an attractive force that acts between any two masses, and this is the weakest of the universal forces, and also works the longest, though, because obviously the moon and the sun and the earth and all that. 77, how is gravitational force increased between objects? Larger masses or shorter distances? Okay. How is gravitational force decreased between objects? Smaller masses or longer distance? So I can have small masses, but then make them shorter distance between them. Or I can have large masses and make them longer. So again, the moon and the earth. If somehow we made the moon greater mass, there would be more gravitational force between the two. If we made it closer together, then they'd have gravitational force. Or I can make the moon farther apart, they'd have less gravitational force. Or if I cut off half of the moon, then it would be less gravitational force. All right, what is centripetal force? It's a center-directed force that continuously changes the direction of an object to make it move in a circle. And then how do satellites orbit? Satellites only need centripetal force provided by gravity and its inertia to maintain its orbit. All right, hope you study this.